Hi, welcome to the lecture on fundamentals of computers. So, we start with the functionalities of a computer. So, if you look at the functionalities of what a computer can do, a computer would take data as input, it stores the data or instructions in its memory, processes the data, generates the output, and the first four steps would be iterated over and over again. Yeah, so if you look at the block diagram, it very clearly says input, process, and output. So what are the advantages of computers? Computers have numerous advantages. So speed, very high accuracy, it has large storage capability, then diligence, because a computer will never get bored. It can do repeated tasks with the same speed and accuracy. Versatile, reliable, automation is possible, and obviously there is reduction in paperwork and cost. So if you look at the applications of computers, computers are almost used in any kind of an application that you name. That is the use of the computer. So right from business to banking, insurance, education, marketing, healthcare, engineering design, military, communication, government services, all departments, you name any department, obviously it will have the usage of a computer somewhere. And these are certain applications, areas where computers can be used. If you look at the generation of computers, it starts with the first generation from 1946 to 1959, where vacuum tube were used. Second generation starts from 1959 and goes on until 1965, where you could find the usage of transistors. The third generation starts in 1965 and ends in 1971, where it starts with the use of ICs, the integrated circuits. The fourth generation starts with 1971 and goes on till 1980, where you have very large scale integrated microprocessor chips called VLSI chips used. And the fifth generation starts right away from 1980, and it basically uses ultra large scale integrated microprocessor chips. Computers can also be classified based on their speed and computing power. So we have personal computers, which is a single user computer system that has moderate powerful features. Then you have something called a workstation. A workstation is also a single user computer, but more powerful than a PC, a personal computer. Then you have mini computers. Mini computer is a multi-user computer system where it could support hundreds of users simultaneously. Then you have mainframes, which are also multi-user computer systems. They also support hundreds of users simultaneously, but the technology used in a mainframe is different from what is used in a mini computer. Then you have supercomputers, as the name suggests, super fast, extremely fast computers, and they could obviously execute hundreds of millions of instructions per second. So this is the architecture of a computer. The central one that you see is called the CPU, the central processing unit, obviously called the brain of the computer, that comprises of the memory unit, the control unit, and the ALU, the arithmetic and logic unit. So you have the input that goes into a CPU and you get the output. This is called the architecture of a computer. If you look at the input unit basically contains devices that basically help the user to enter data into the computer. This input unit is a link between the user and the computer, and obviously the job of an input device is to translate the information into a form that is obviously understandable by a computer. So when you look at the various input devices, numerous devices are available, right from keyboards to mouse to joystick to light pens, trackballs, etc. Then we have the CPU, otherwise called the Central Processing Unit. As I mentioned, the CPU is considered to be the brain of the computer. Well, all kinds of data processing operations are carried out by the CPU. The CPU basically stores data, intermediate results, and programs. And CPU has three components: the arithmetic logic unit, the memory unit, and the control unit. So then you have the output unit. The output unit basically contains devices that will help to get the information from a computer and then provide it to the user. Obviously, this output unit is also a link between the computer and the user. So the job of an output device is to translate the computer output into a form that could be understandable by the user. There are lots of output devices, right from your monitors to graphic plotters, printers, and speakers that basically provide audio output. These are certain output devices. Then you have memory. Memory is basically divided into three types. 1. Cache memory. 2. The primary memory or main memory. 3 is the secondary memory. So if you talk of the cache memory, a cache memory is a very high speed memory, and this cache memory is basically used to speed up the CPU. This cache memory is smaller in size and it serves as a buffer between the CPU and the main memory. The job of a cache memory is basically used to hold the data and the programs that are more frequently used by the CPU. Cache memory comes with certain advantages. Obviously, it is faster than the main memory. It consumes less access time compared to the main memory. And the programs can be stored there, and probably those need to be executed within a short duration of time. And cache memory is always a temporary memory. It stores data for temporary usage. Then you have the primary memory, otherwise called the main memory. This primary memory or main memory basically holds data and instructions on which the computer is currently working. This main memory is also having some kind of limited capacity, and the data will be lost when you turn off your computer. This main memory is made up of some kind of semiconductor devices. These memories are comparatively slower when compared to the registers that are available in a computer. So any kind of data and instructions that need to be processed are basically put into what is called the main memory. Basically, it is two subcategories, the RAM and ROM, ROM and RAM. RAM is random access memory, ROM is read-only memory. Then you have the secondary memory. The secondary memory is basically called an external memory, and it is non-volatile, meaning even if you turn off your computer, the data that is basically stored in a secondary memory is not lost. Still, this secondary memory is also slower compared to the main memory. But the advantage of the secondary memory is basically used to store all kinds of data in a permanent fashion. So a CPU cannot directly access this secondary memory. So basically it will make use of what are called the input-output routines in order to access the secondary memory. So whenever you have some kind of data that resides in the secondary memory, then obviously they need to be transferred to the main memory, and only then the CPU can access data from the secondary memory. Some typical examples of secondary memory are hard disks in your computers, the CD-ROM that you use, DVDs, and all these things come under the category of what is called the secondary memory. So RAM, as the name indicates, is random access memory. This random access memory can store data, programs, and results. This is a read-write memory, and it stores data until the machine is working. As soon as you switch off the machine, the data in this will get erased. RAM is of two types: SRAM, otherwise called the static RAM, and the DRAM, otherwise called the dynamic RAM. Then you have the ROM, the read-only memory. ROM, the read-only memory, as the term indicates, you can only read, you cannot write it into it. So this is obviously going to be non-volatile in nature. The information that's stored in an ROM is going to be permanent. So an ROM basically contains a set of instructions that will be required to start your computer, boot your computer in fact, otherwise called the bootstrap. And this ROM chip finds usage not only in computers but also in electronic items like washing machines, microwave ovens use this ROM chip, to start and keep it working. So you have, a lot of varieties that come in this ROM chip called the PROM, programmable ROM, erasable programmable ROM, and electrically erasable and programmable ROM, and so on. The ROM comes with advantages like non-volatility, cheaper than RAMs, easy to test, more reliable than RAMs, and you cannot accidentally change the contents. And ROM is all static. They do not require any kind of refreshing. So contents are all known and can be verified at any point of time as well. Then you have something called the motherboard. This is how a motherboard basically looks like. The motherboard serves as a single platform to connect all the parts of your computer together. So it will basically connect the CPU, your memory, your hard drives, optical drives, SD cards, everything, all ports, expansion cards, they're all connected via this motherboard using cables. So the motherboard is basically called the backbone of a computer. So whenever you talk of memory units, the lowest one is called the bit, otherwise called the binary digit. So bits are very much obvious. Computers can only understand bits. So when I say binary digit, 0 and 1. 0 might represent a passive state, 1 might represent an active state in an electric circuit. 4 bits make a nibble, 8 bits make a byte, and the byte is considered to be the smallest unit that can represent a data item or a character. Then you have words. So a word, like a byte, is a group of fixed number of bits processed as a unit. So it can be 8 bits, 96 bits, and so on and so forth. So obviously a computer will store information in the form of words. So we have some things like KB, MB, GB, TB, and PB that you might have seen. So 1024 bytes make up 1 KB, 1024 KB make up 1 MB, megabyte. 1 gigabyte is 1024 MB. 1 terabyte, most of the hard disks, external hard disks as well, come with this storage capacity, right? 1 terabyte is nothing but 1024 GB, and 1 petabyte is 1024 terabytes, such a huge space. Then you have something called a port. What is a port? A port is a physical docking point using which an external device is connected to a computer. It can also be programmatic docking point through which the information flows from the computer to the program or over the internet. That's called a port. So external devices are connected to the computer using cables and ports. So what are ports? Ports are nothing but slots on the motherboard into which you can plug a cable and then connect an external device to it, like a mouse, a keyboard, a monitor. That's why you call it as an USB port, a HDMI port, and so on, right? So that is what is called a port. Yeah, this is how it looks like. Yeah, you are very much familiar with the lots of ports. Ethernet, it's RJ45, modem is RJ11. Then you have the VGA ports, S-video, HDMI, DVI, digital video interface, right? PS, serial, parallel, game port, etc. Right? This is how ports look like. So what is a serial port? A serial port basically is used for connecting some kind of external modems or the old computer mouses that you have. Now we have almost Wi-Fi mouses, right? Wireless mouses. So it's a 9-pin or a 25-pin model, and the data travel rate is 115 kbps, kilobits per second. That's called a serial port. Then we have something called a parallel port. A parallel port normally would be used to connect some kind of scanners and printers in olden days, also called the printer port, a 25-pin model that's IEEE 1284 compliant. Nowadays, we have printers that also connect through Wi-Fi, USB, and so on. The next one is called the PS2 port, and this port is basically used for old computer keyboards and mouses, otherwise called the mouse port. Most of the older computers that you would have seen has two PS2 ports. One you can connect the mouse, the other one you can connect the keyboard. Older desktops, yeah. Then you have the USB, which is very much common to you all, USB ports. They connect all kinds of external devices like the hard disk, printers, scanners, mouse, keyboard, etc. Introduced in 97. Minimal is 2 ports, per computer. The data travel rate is about 12 Mbps. And they're all USB compliant devices, and they all can get power from a USB port. And that's how you can probably charge your mobile or your power bank and so on using a USB port on your computer as well, right? Then you have the VGA port. The VGA port connects the monitor to a computer's video card, almost similar to a serial port connector. Then you have power connectors, very much common. It's a 3-pronged plug, where it will connect the computer's power cable that plugs into a power bar or a wall socket. There are 3 things, 3-pronged plug. It's not a power connector. And nowadays we use what is called a Firewire. A Firewire port mostly, connects camcorders and video equipment to the computer, transfers large amount of data at a very fast speed. Data travels at around 400 to 800 Mbps, invented by Apple. So all the MacBooks, comes with what is called a Firewire port. It might have a 4-pin connector, a 6-pin connector, or a 9-pin Firewire connector, and so on. Then you have Ethernet ports. They connect to a network and a high-speed internet. You can connect the network cable to a computer, and this port basically resides on an Ethernet card. If you see the rate at which data travels in this, it ranges from somewhere between 10 Mbps to 1000 Mbps, and this basically will depend on the network bandwidth. Then you have gaming ports, basically used to connect a joystick to a PC. So nowadays we don't have that, so it's all USB, Universal Serial Bus. Then what is a hardware? A hardware is nothing but a physical and a tangible component of a computer. So what is a physical and tangible component of a computer that you can see and touch? Like keyboards, mouses, printers, monitors, CDs, DVDs, hard disks, etc. There are certain internal components also like the CPU, the motherboard, RAM, and all these comprises of what is called the hardware that makes up the computer. So obviously hardware and software are complementary. They are mutually dependent on each other. So both need to work together to make a computer that could produce some kind of a useful output. So software without a supporting hardware or hardware without a supporting software is of no use to anybody. Yeah, it's going to be useless. So both are important. So what is a software? A software is nothing but a set of instructions basically written to perform a well-defined function. So it's nothing but a sequence of instructions to solve a given problem. So typically software is divided into 2 types, system software and application software. If you talk of system software, a system software is nothing but a collection of programs that basically help the hardware to do its job. And these kind of system softwares are all prepared by computer manufacturers, and they are all written in low-level languages. And only then, the computer can understand. And these kind of system software basically will serve as an interface between the hardware and the end user. Some typical examples of system software are OS, compilers, interpreters, assemblers, etc. Then you have the application software. An application software is basically designed to satisfy a particular need of a customer or an environment. Any kind of a software application that you see that is prepared in a computer lab will come under the category of an application software. Some of them which are very familiar to you are MS Office, Adobe Photoshop, etc. So whenever we talk of the number system, you have 4, right? Binary number system with base 2, represented with digits 0 and 1. You have an octal number system with base 8, ranges 0 to 7. Then you have a hexadecimal number system with base 16. It uses digits from 0 to 9 and letters from A to F. And the other one is very much obvious, the fourth one, which you are very much aware. It's called the decimal number system, right? With base 10 that we use on a day-to-day basis. And it is represented with digits from 0 to 9. So what is data? Data is nothing but a representation of facts, concepts, or instructions that are basically written in a very formal manner. And data is going to be very much helpful for communication, interpretation, and processing. So this communication, interpretation, and processing needs to be done either by humans or it has to be done by an electronic machine like a computer. And both human or electronic machines would need meaningful data to process and get the desired result. So that is the importance of data. Then what is information? Information is organized or classified data. Data is raw. Information is organized, refined data, you can say. And information will convey some kind of meaningful value to the receiver. In other terms, what is information? Information is processed data on which decisions and actions are based. So whenever information needs to be helpful, it has to be available at the correct time with higher accuracy, and information need to be complete in all aspects. These 3 characteristics are very important. Time, accuracy, and completeness need to be importantly considered for information to be useful. Now, coming to the operating system. What is an operating system? An operating system is a program that has the following features, like a program that will act as an interface between your software and the hardware. That sits somewhere between the hardware and the software. That's called the OS, the operating system. So an operating system is an integrated set of specialized programs that manages the resources and operations on the computer. It is a specialized software that controls and monitors the execution of all other programs that reside in the computer. So you can see you have a user, you have applications, and that's where the operating system basically sits, and below which you have the hardware. What are the objectives of the operating system? So the operating system is defined with certain key objectives. Like it will make the computer system convenient to use, it will hide details of the resources from users, it provides a very good interface, it manages resources, resource tracking, conflicting requirements can be mediated, and resources can be efficiently and fairly shared among users and programs. Keeping all this in mind, there are certain characteristics of operating systems like memory management. As the term indicates, you need to manage the memory, primary memory, allocation, and so on, servicing, etc. Then you have processor management. Basically allocates processors to a process, and then after the job is done, you need to deallocate, when you no longer need it. Then you have device management. Device management basically is used to keep track of all devices. And then you have file management, allocation and deallocation of resources and files, right? So these are 4 key characteristics of an operating system. In addition to that, you also have a few other characteristics like security, which will basically take care of unauthorized access to programs and data, where you could have passwords, fingerprints, etc., job accounting, control over system performance, interaction with operators, error detecting aids, where you have dumps, traces, error messages, and also coordination between other software and users. So these are certain key characteristics of the operating systems. So if you talk of a computer network, this is the last part. A computer network is a system in which multiple computers are connected to each other to share information and resources, like this, right? So this has given you an overall understanding of what is a computer, what is its use, what is a network, what is an operating system, what is a hardware, software, and so on and so forth. So this concludes the introductory session on what a computer is and what typically a computer can do. Thank you.